simple data science. So today we are going to discuss one of the important topics, that is the what is machine learning. And when I was starting my career in the field of data science, this question always comes to my mind, that what is machine learning? Okay, so first we're going to introduce that what is a machine learning. So machine learning is a branch of artificial intelligence. Okay, it enables the system to learn from the data. This is the most important, that machine learning needs the data. You need to remember that whenever you are trying to make a decision, you need a data. So machine learning are using the data part and improve from experience. And in the third point, I try to explain that, as you know, the machine learning is transforming industries by automating decision making processes. So all the industries nowadays, everything is they are every industry they are using the machine learning stuff. So in this slide, what I try to do is that we are try to interlink that how these three terms are interlinked with each other. That is the AI, ML, and a deep learning. So just like I will show something. Okay, so it's just like you can consider it as a AI. Okay, this is the your AI part. So as you know, it's a broad concept of machines mimicking the human intelligence. So it's a subset of you know I mean the ML is a subset of AI. So this is your ML part. Okay, it's a subset of AI that learns from the data. All right. So what a deep learning is all about? It's a subset of ML using neural networks with the many layers. When we are adding a layers, that become deep learning. So this is your deep learning part. Okay. Okay. So what is the importance of a deep learning? So the powers, modern technologies, not only these industries, but a lot of industries nowadays using the ML in order to make decision making, for automating decision making. They are using the ML parts. So it helps in personalized experiences, predictions. It helps out for predictions and optimizations. So in the next slide, so we are trying to divide a machine learning into three major types. That is the supervised learning, they train on label data. So in a supervised learning, we have a label data. That means that the target is given. Okay. So in an unsupervised, there is no label data. That means there is no an answers. Okay, in a data set. And reinforcement learning learns through the rewards and punishments. So these are the major types of the machine learning. Okay, so what is the supervised learning is that we have where we have the input and the output is given, that what is the input and what is the output. For example, when you are trying to classify that whether the email is a spam or a real one. So there is a two classify. The two columns should be given. This is the real one and this is the spam one. So in order to make, for supervised learning, you need to have your label data. Should be the answers given. This is the answer already given to it. then it have to differentiate, it have to classify through it. So the examples could be, for weather prediction, they could be. So uh, journal algorithms are like the linear regression, decision trees. This is just like the algorithms, which is the type of supervised learning. In unsupervised learning, as we have discussed, there is no labels, there's no answer. So we need to make them in. We need to have a clustering part. We need to differentiate a data through making a clusters. So examples could be like marketing, segmentation, anomaly detection. So these are the examples, and there are a bunch of examples around us. Um, the common algorithms are k-means, clustering, and PCA. So in reinforcement learning, the learning through trial and error. So there are three agents, which are involved. It's just like three components. It's just like agents, actions, and rewards. So they are mainly used in a gaming industry and robotics, because you are trying to teach a robot, that you have done an error. Now you need to correct yourself. So it is like, self-correcting itself, that, I have to do this, I have to do that. And if it make a bad decision, so bad action, then we will have some punishment on it, and it will try to learn from it next time, and we will give a reward for it. So it's worked like that. Okay, how machine learning works. So the first thing we need to remember, the first thing for in order to have a better machine learning algorithms work, we need to have a data collection. And the second thing is like we need to have clean the data and prepare the data. So as a data scientist or as a data analyst, the a lot of your time will spend on data pre-processing. That is the cleaning of the data, because in a machine learning, what we say is that garbage in, garbage out. So if you are giving it a garbage, your answer could be a garbage as well. So you need to give or feed the data which is more clear, which is more transparent, in order to to feed to the algorithm, in order to have a precise decisions, a good decisions. So the third thing is the model training. Then what we are doing, that we are feeding the data into ML algorithms and try to train it. Then we have to evaluation parts, that is the test the model's accuracy. And the last thing is your deployment, that you can deploy on Azure, GCP, wherever you want. It's just like it's a real-time applications, real-world applications. Okay, the popular ML algorithms are the linear regression, logistic regression, decision trees, random forest, support vector machines, k-nearest neighbors, and neural networks. So there are a bunch of machine learning algorithms available nowadays. Applications of the machine learning. So I must say, this is not limited to these only industries now, though they are using everywhere around the world. It can be used for the healthcare, for example, for predictions and diagnosis, for finance, for fraud detection, and retail recommendation systems, inventory forecasting, for transportation, self-driving cars, and traffic prediction. So, what I means to say that it has been used, or it is used by every industries nowadays. So what are the challenges? So we need to have a large data because machine learning algorithms work when the data is large. Means they can work on small data, but they if you are giving a large amount of data, then it is easy for machine learning algorithm to make a decision, a precise decision, a good decision. So there should be a high quality data. I said, because the data is the most important and there should be high quality. There should not be errors. It should be a clean. So it's just like garbage in and garbage out. You need to make sure you are not putting some garbage stuff into algorithms. So machine learning is facing the overfitting and underfitting. So what is the overfitting and underfitting? I will just try to highlight that whenever machine or algorithms try to learn each and every point, and even it will try to learn the noise, then it becomes the overfitting. The underfitting is just like, it's machine learning didn't able to learn the things which is required by the algorithm, so it doesn't able to differentiate or classify. So whenever you are giving the unseen data, it become, the machine learning become the algorithm become confused, machine learning algorithm become confused that how to differentiate. So it is known as the underfitting. And sometimes we call it the generalization part. It doesn't able to work well on unseen data. So the next point is just like we need to take care of the biases in the data. For example, we need to be data should be more generalized. It should not be biased, or it should not be pointed out a single stuff. Then the machine learning the machine learning algorithms will become unfair. There should be a fairness concerns. So the last point is that to interpret in the transparency of the models are the big challenge, because we need to we need to interpret that what the data is saying after feeding out, after performing each and every step. We need to make sure. Okay, so what are the future outlooks? So increased adaptation across all industries. As this point is already, I mean, this point is just nearby to end up. It's just like now it is using by all the industries nowadays. So there should be a greater focus on the ethical AI. So there are the AI ethical concerns nowadays, which is being raising. So we need to more like integrate with the IoT, Internet of Things, the blockchain, and other technologies. It is just like creating a lot of new jobs. Although nowadays the big question is that the machine learning and AI just try to replacing a human. So there is the big debate nowadays. Controversies are going on. So those people who are more related to a take on AI, it will create more opportunities, I must say. And those who are, the daily basic jobs they are doing, so their job gonna be in danger in the future. And nowadays you can see. So and for the career paths. Okay. So what is conclusion? Conclusion is like machine learning is revolutionizing technology and businesses. It allows the system to learn and adapt from data. The future of ML is bright and endless possibilities. There are, yes, I agree, there's endless possibilities. Keep learning and experimenting with ML techniques. So that is my suggestion. Thank you so much for watching this video and subscribe. Although I have didn't upload a lot of videos up there, So I am expecting to subscribe, and I try to, give me more suggestions and comments if possible. Thank you so much for your time.